everyone, welcome to Module 2. Again, this is Unit 3, Standard 1, and now we're just going to do some practice problems. So, just a reminder, acceleration in the x will always equal 0 meters per second squared, and if it's shot, this is only the case, if it's shot horizontally, then the initial velocity in the y direction will be 0. Okay, so these are your main two things that you have. So it says a cannon was horizontally shot from 45 meters per second from the top of a castle at 300 meters above ground. Determine how far in the vertical and horizontal directions the cannonball would be 2 seconds after shot. All right, so the way we address this, right, we first of all, we have the cannon that is 300 meters above ground. We know that it's 300 meters above ground, but we actually don't know if it's going to hit the ground. The only thing we know is that it's in travel for 2 seconds. So let's try this. So what's in the x? What's in the y? So do we know dy? The question is, no, we don't know that. We don't know how far it's going to be, right? We're looking for that. And we're also looking for dy. It's a two-part problem. So we're going to have to try to figure out how far did it fall down. All right, so let's try to figure out what we do know. Well, we know that the initial velocity in the x direction, that was 40 meters per second. The initial velocity in the y direction, that's 0. The final velocity in the x direction is also 40 meters per second. Sorry, 45 meters per second, not 40. 45 meters per second. Acceleration in the x direction is 0 meters per second squared, and time is 2 seconds. So that's pretty much all we know for the x. For the y, we know VIY is 0. VFY is actually unknown. AY is negative 9.8 meters per second squared, and then time is 2 seconds. Okay. Good. So notice in class we mentioned this. So again, if acceleration is 0, then you will have to have 4 things in order to solve for dx. So notice we actually have those 4 things. We have each one to solve for dx. So dx we can solve for, and let's do that. So distance, using this equation, distance is equal to initial velocity times time plus 1/2 at squared. You can solve for dx. So initial velocity was 45. So 45 meters per second times time, which is 2, plus 1/2 times a, which is 0, times time, which is 2. All right, so anything times 0 is 0, so that's going to cancel. And you have dx is equal to 45 times 2. So dx is equal to 90 meters. And that's dx. All right, so let's solve for dy now. So what is it that we know in dy? So we know for dy that the initial velocity is 0, acceleration is negative 9.8, time is 2. So we can actually use the same exact equations. Distance is equal to initial velocity times time plus 1/2 at squared. You can solve for this because you know acceleration, you know time, and you know the initial velocity. So distance in the y is going to be 0 times 2 plus 1/2 times a negative 9.8 times t squared, which is 2 squared. All right, so solving this out, you get 0 times 2 is 0, so that entire term cancels. Then 1/2 times negative 9.8 times 2 squared. So negative 9.8 times 1/2 is a negative 4.9. That times 2 squared is going to be, this is pretty much 4. So 4 times a negative 4.9 is going to give you a negative 19.6. So dy, right, it's only fallen 19.6 meters after 2 seconds. So that's pretty much it. Oh, this kind of, okay, so looking at this, so this would be 90 meters, and dy would be negative 19.6. So it would have traveled a total of 90 meters horizontally, and it would have fallen 19.6 meters. Good. All right, go ahead and try the two problems.